Hello class. This is going to be a very brief recording on normalization. And once again, I'm going to ask you to print out your notes before you get into this recording. Okay, I have your notes in front of you. Okay, what is normalization? Basically, we've actually been working towards normalization throughout the semester. I just haven't used the term. When you learned how to map the ER diagram into the relational database, that actually came up to a normalized relational database. And you just didn't know that, but that's what it is. Okay. But one of the main things that you're supposed to be taking out of this class is a normalized database. How would you develop a normalized database? And like I said, if you know all the mapping rules of going from the ER diagram to the relational database, that automatically takes you into a normalized database. But anyway, we want to take normalization from a different angle now. A lot of times when you go to work in a particular company or go to work someplace, you're going to have a set of tables. They're not going to have an ER diagram and have you design the database way from scratch. So you're not going to be given the chance of mapping the tables and applying all the fancy rules that you learned. Well, you may not be. You may be, but a lot of times you walk into a scenario where there already are tables. Okay, there's already a database. Now, the question though is the database normalized? Is it the most efficient that you can make it? Okay, when we talk about normalization, we're basically talking about how efficient can we go with the database. So is it the most efficient that you can make it? That's what we would talk about in a normalized database, is how we can make it more efficient, or as I said, is it the most efficient? Okay. So if you look at slide 3, they should be noted that the redundancy, no addition, deletion, or update anomalies. And what that means is if you add something to table A, that's all you need. You should have to do. You should not have to add something to table A. And because you added something to table A, you've got to add it to table B and to table C and to table D. That doesn't make sense. If you have a normalized database, if you needed to add something about a customer, you added it to table A, well and good, you added it to table A. If you need it for table B, you would just join up table A and table B. Okay, so that's what we're talking about when we're looking at a normalized database. Okay, so are we sure there is no redundancy in a normalized database? Okay, the basic things is when we do normalization, there's a first normal form, there's a second normal form, there's a third normal form. I'm on slide 5 now. And actually there are more normal forms than the third, but in this class we pretty much stop with the third normal form. And actually most of the world today is still in the third normal form, and that is pretty much considered good enough. There would be exceptional cases when we would consider things to be in the fourth, fifth, and etc. normal form, but usually we're done with the third normal form. Okay, so what is the first normal form? You have to look for repeating groups. There should be no repeating groups in your tables. That's the first normal form. Second normal form, you remove non-full key dependencies. That means every attribute in the table should be fully functionally dependent on the primary key of that table. Okay, there should be no attribute that is not dependent on the primary key of that table. For example, if you've got a student table, an attribute like, I'm not sure, but an attribute like that's not related to you, maybe not related to a student, okay, should not be in that table, because everything in the student table should be related to the student. So it's, in a way, it's related to the primary key. Okay, the third normal form is you remove the transitive dependencies. And what is a transitive dependency? That's when attribute A is dependent on attribute B, which is dependent on attribute C. So when something is dependent on something which is dependent on something else, like there's one thing dependent on another thing which is dependent on another thing, that should not exist in a table. Every attribute should be dependent on only the primary key and only the primary key. So every attribute should be dependent on only the primary key, and that is the third normal form. Okay, there are a few examples that that I'm going to just kind of let you read over, but I just wanted just to give you the very brief description of what the normal forms are. Going to slide 11, what are the addition, deletion, and update anomalies? This means that if you add, delete, or update a database, you should not have null values in other fields. Okay. And with this, I'm going to end you in the lecture, and it's a lot on developing. I've posted some exercises, and it really is going to help for you to do those exercises, and I'm going to post feedback, and I think that will help you learn the normalization process further and how tables should be normalized. But in the normalization lecture, we're basically coming in from the angle of, well, I've got a whole bunch of tables. Are they really normalized? If you don't have tables correctly normalized, what you're going to have is duplicate data all over the place. You're going to have redundancies. You're going to have inconsistencies, because you will have updated something in one table and it will not be updated in the other table like it should. Primary keys dependent on each other, so your joins will not be working reasonably or will not make sense, and so forth. And that's what normalization is all about. Okay, with that, I'm going to end the lecture. Bye.